Great. So yeah, first of all, thank you for the invitation to give this talk today. And the title of my talk is Generative Logic Teaching Prolog in Art and Design. My name is Stefan Jendreiko, and I am professor for digital in two parts. In the first part, I try to explain why I teach Prolog, and in the second part, I try to explain how I try to do it. Okay, so Prolog is part of my curriculum here for BA and MA students alike. The course that I give is a course for beginners. In this course, we are not only experimenting with Prolog, we are also working on how to teach Prolog. So my whole approach, how to teach Prolog, is still under construction. Let me say a few words about how design students are so that you get an idea about the target group. So normally it is the case that design students want to become graphic designers, illustrators, typographers, or photographers. They don't want to become programmers, computer scientists, mathematicians, or logicians. So the question is, why do I think it is important to teach Prolog in the context of art and design? Well, I do it because I think it is important to make the design students good designers. So what makes a good designer? Designers should be conceptually strong, highly reflective, critical, and they have to be able to develop original artistic ideas in order to help shaping a human-friendly society. And I think Prolog is a perfect tool for shaping these skills. Why? There are three main reasons that I want to point out here in part one of my talk. Reason number one. Okay, we say a good designer is conceptually strong and is highly reflective, which means a good designer is capable of reasoning in a clear and systematic way. Well, Prolog opens the door to step into logical thinking. Dealing with its automatic backward reasoning engine brings reasoning as such into the forefront. So Prolog is a great tool to detect, reflect, and improve your own ways of thinking. Learning Prolog, you can learn about logical thinking and logic in general, about backward reasoning and forward reasoning, and how to tell one from the other, and about how to integrate both methods of thinking into your own way of reasoning about the design process in order to handle it in a systematic way with respect to how to organize it and how to reflect about it. The second reason, because the computer itself is a logical machine and programming is based to a great deal on logical thinking, teaching Prolog is for me an ideal tool to foster what is called digital literacy on a fundamental level. And that is what you need as a designer today, because as a designer, to be highly reflective, critical, and conceptually strong in a digital society, you need digital literacy. And learning Prolog, you can shape your digital skills and your digital literacy on a fundamental level. Because working with Prolog, you can learn about what a computer is. Well, it is a logic machine, and what you can do with it and what not because of that. You can learn about basic concepts of AI, especially the fundamental difference between symbolic and sub-symbolic AI. You can learn about fundamental concepts of computer science and programming like data structures and search algorithms. You can learn about linguistics and generative grammars. You can learn about semiotics and the difference between syntax and semantics. And you can learn about fundamental mathematical concepts like graph theory, lattice theory, set theory, or combinatorial theory. The great advantage of Prolog as a teaching tool for getting people in touch with all these topics is for me that you can deep dive into the big questions of computer science and digitality by writing minimal code. So this is the second reason why I think it is important to teach Prolog to artists and designers. Now, the third reason, here I need to stretch out a little bit to give you context. The arrival of the computer finds the artist and the designer in a very special situation. And we have to deal with this situation in order to stay relevant in the social process of shaping a human-friendly society. Okay, what is this situation? Let me try to explain it by bringing on some thoughts that Max Bense did lay down in books like the one you can see here, Programmierung des Schönen, from 1960. You can roughly translate it into Programming Beauty or How to Program Beauty. Being professor for aesthetics at the Ulmer Schule für Gestaltung in the 50s, Bense was confronted with a then new digital computer, and the following idea came to his mind. As an artist, as well as a designer, from now on, you don't write, paint, or compose anymore, but you write the program that does it for you. This groundbreaking idea, which came up by then, had a deep impact on modern art and design after 1945. It did mean a big shift in how to understand art and design. It was also Max Bense who understood as one of the first that the computer can not only be used to solve equations, but also to generate aesthetic objects. And seeing very clearly the opportunities as well as the dangers the computer has to offer to artists and to society as a whole, he and his students developed the operational theory of generative aesthetics, what is known today as generative design. A survey of key ideas of generative design you find in this book by Frida Nake, one of Bense's students and one of the pioneers of computer art. Frida Nake describes super clear what the situation is. What does count from now on is no more the form, but the formula that generates the form. And this is the situation students of art and design have to deal with today. And just to give you a little bit more of art historic context here, the theory of generative design is unthinkable without the art theory of Paul Klee, namely that making art of any kind means to think in sequences in order to create patterns. Paul Klee identified the generation of sequences as the general principle that underlies all forms of making art. Let it be poetry, music, dance, film, painting, graphics, sculpture, or storytelling. And here, you guess it, comes Prolog into play. Because to state it with the words Markus Triska once said to me, Prolog was made to describe sequences. And so I think Prolog has everything on board to be a powerful language in the context of generative art and design. So this is the third reason why I teach Prolog in this context. At this point, let me recall the idea of Paul Klee that the sequence is the universal structure underlying all forms of making art. I want to take this idea one step further and say that there is a fundamental relation that exists even on a deeper level than the structure of sequence. And we use this relation in order to create the sequences. This relation was described by Felix Hausdorff in his book Grundzüge der Mengenlehre like this: A for B, which means in English A before B. You find this fundamental relation as a generating structure in all kinds of human activities. You find it in storytelling. You find it in music. You find it in film. And you also find it in the industry, in everyday life, for example, at assembly lines. This relation belongs to a set of fundamental relations. Another one is B contains A, pointed out by Garrett Berkhoff in his book about lattice theory. With this relation, for example, you can describe almost every image formation. Here you see a painting by Josef Albers, and of course you can describe it with this relation. The frame contains the first square contains the second square contains the third square, and the third square contains the fourth square. So transitivity. So my hypothesis is that it is these fundamental relations that we are performing whatever we do. Let it be making music, drawing sketches, painting pictures, telling stories, doing logic, doing mathematics, doing computer science, doing sports, taking a walk, whatever. These are deep fundamental relations where all kinds of human actions are based on. And the great thing is, you can explore them on a fundamental level using Prolog. Because Prolog has this clear and simple syntax and has this great advantage that we can express these fundamental relations very easy. And that to me is the real magic of Prolog. Which brings me to part 2 of my talk. How to attract design students to Prolog. Now, first of all, make them experience that fundamental generative power of Prolog and how easy it is to describe with Prolog what they are most interested in, namely visual relations. And second, make the students clear working with Prolog does not mean to learn just another programming language, but working with Prolog means to cooperate with an AI, with a special kind of AI, an electronic brain that is able to perform backward reasoning, and that it is you who can unleash the generative power of this automatic backward reasoning. Okay, how do I introduce students to Prolog in the course for beginners? In the first session, I introduced students to the whole matter of logic programming, AI, and generative design via a classic example of a logic machine. It is the one you can see here, and I guess you know it. It was invented by Raimundus Lullus in the 14th century, Ramon Lull. Lullus was one of the first who did design machines for logic reasoning. He used the principle of combination. Technically, it is a Volvel, which means circles within circles that you can move against each other. To me, he is a pioneer of what I call generative logic. Raimundus Lullus writes that his machine can be used for 3 reasons: for ars investigandi, for ars demonstrandi, and for ars inveniendi. These 3 arts combined give the ars magna. In other words, you have to be able to explore, to invent, and to demonstrate to be a master of arts. So here you have core skills, what makes a good artist and a good designer in a nutshell. I rewrote this Ars Magna machine in form of a simple Prolog code. You can see it here. So here you see the database, which resembles the 3 rings. And here you see the rule, which just says, given the combination R1, R2, R3 is given if ring 1 is given and ring 2 is given and ring 3 is given. And this code is the blueprint for almost all the code we are writing and experimenting with in the beginner's course. 2 things are added later, transitivity and DCGs, but that's it. The code does come along with 3 exercises. Explain your friends in your own words how the mechanism, which is the inference machine in Prolog, works. Develop your own symbolic system and start to experiment. And here I show you 3 examples what students develop out of this. The didactic strategy here is keep the coding simple and make it fun for the students to explore the generation of graphics and other sequences. The coding is kind of data log oriented. Set up a database of basic elements, combine these elements to bigger modules by developing intelligent strategies of queries, combine these modules to even bigger modules, and in order to do so, learn how to work with the backward reasoning engine effectively. The coding is about how to build a generative system yourself, using this logic inference engine as the central building block. And that is exactly the key idea of what I call generative logic, using automatic deduction to generate sequences in order to create aesthetic patterns. Aesthetic patterns of any kind, including sequential image formation. As you can see here, later in the course, we also switch to DCGs. So here you see a DCG version of a code a student has written, and here you see the output. And because the students build their own generative system, the course is about digital empowerment. Okay, in the database, we just use ground terms. The programs are just positive programs, no negation is involved, and we stay with monotonic reasoning. Keeping the coding that simple means that there is no distraction by getting lost in writing code. Instead of tackling key ideas from the domain of computer science, as well as from the domain of computer art and generative design, learning to think conceptually. And within the course, the students find the time to deep dive into these concepts of both domains and gaining a general understanding for the generative structures that are underlying the digital aesthetic output. As I said before, the great advantage of Prolog as a teaching tool is for me that you can deep dive into the big questions of computer science and digitality by writing minimal code. So my strategy for the beginners course is simple code, complex topics. With the result that the code the students are writing is super simple, but it is at the same time deeply reflected. Which brings me back to the beginning. What makes a good designer? A good designer should be conceptually strong, highly reflective, critical, and he has to be able to develop original artistic ideas in order to help shaping a human-friendly society. And I think Prolog is a perfect tool for shaping these skills. But there is another reason. Teaching Prolog means trying to explain Prolog, which means to reason about Prolog. And this is what we are doing here in our education group week after week. And reasoning about automatic reasoning is exciting. Thank you. Dziękuję, muchas gracias, mille gracias, merci.